what we have learned in class is this equation of the path of a projectile, which is y equal x tan alpha minus gx squared 2u squared cos squared. For the first question, what is given to us is this point PHK, alright, and we want to throw a projectile from O so that it will pass through this point PHK. Okay, but with one restriction. The restriction is with a fixed velocity u. You are given some velocity and you are given some point. You want to throw a projectile so that it will hit this point. So some of you may throw it simply in this way, but some of you may be a bit clever, okay, and throw it, the projectile, in this way. Of course, some of you may be thinking, well, maybe I can throw it another way. But what we will show in this problem is there can be only two possible paths for a projectile to pass through a given point. So before solving that first problem, let us again have a look at the equation of the path of the projectile. So over here, x is fixed because the point P is given to you. Y is also fixed because the point P is given to you. U is also fixed, okay, from the question. And the only thing that can vary is this angle alpha. So if you analyze this equation correctly, you will be seeing that all of them are constants except alpha, which is the variable. And over here you are already having a clue that we can have two possible values of alpha. So how do we know that? It is because of this cos square alpha. Once you have a square and an equation, it is likely that this equation will transform into a quadratic equation because of this square. So that is our task. We will transform this one into an equation of the form ax squared plus bx plus c equal to 0. And how are we going to do it? Tan alpha, we will keep it as it is. Cos square alpha, we will transform this one into tan square alpha. Keep it as it is. Sec square alpha, you can write it as 1 plus tan square alpha. So over here you are having tan alpha, tan square alpha. Again, because we want to transform into quadratic equation, okay, so we have to keep that standard form ax squared plus bx plus c. We will transfer everything to this side. Okay, you will be having something like this. Okay, and over here instead of x we are having h, and instead of y we are having k. So if you see this one, it is indeed a quadratic equation. Tan alpha, the variable over here is tan alpha, and it will give two roots tan alpha 1 and tan alpha 2. So this is done. Again, let me highlight what we were doing. You were having a point PHK, it was given to you. You are throwing projectiles to hit this point. The velocity is fixed. What we were getting that there are two possible angles, alpha 1 and alpha 2. Okay, so you can throw the projectile in two different directions with a fixed velocity to pass through this given point P. For the second question, what we are having, again we are having a point P, it's given to you. Again, let us denote it with HK. You are throwing a projectile with different velocities in different directions to pass through this point P. So U, it can vary. V can also vary. H and K, they are fixed. Okay, so if you throw a projectile with too much of a small velocity, it won't pass through this point because the velocity is insufficient for the projectile to pass through this point. So you will have to keep on increasing the velocity and also maybe change the direction so that the projectile will pass through this point. Okay, so maybe for some velocity and some angle, okay, you will be having this projectile to pass through this point. So what is required for us to do in this second problem? We have to find the minimum velocity so that the projectile would pass through this point. Again, I repeat, u it can vary, v it can vary, but we have to find the minimum velocity, because if we throw it with too much of a small velocity, it won't pass through this point. Okay, so how will we do it? Again, we will transform it into this quadratic equation like we did in the first question. Okay, just to clarify something, some of you may be thinking, okay, because in the first question, u is fixed, but over here, u is not fixed. That does not matter. Even though the equation is the same, we just have to keep in mind that in this question number 2, u, it is not fixed. Okay, so this one, it is a quadratic equation. A, it is gh squared. B equal minus 2u squared h. C, it's this term, gh squared plus 2u squared. Okay. Again, we will use the clue that this one is a quadratic equation. Okay, we want a real situation. Okay, what you are doing, okay, it should happen in the real world. At least you can think it in that way. The angle that you will be getting, they should be real numbers. They cannot be imaginary numbers. Tan alpha, it has to be real. The quadratic equation above, it will have real roots. It will have real roots when b squared minus 4ac is greater or equal to 0. So what we will do, we will plug in the value of b, a, and c into this inequality. We will be having this. So from this line, we will divide by 4h squared. Next, what we will do, we will keep terms containing u on one side. The rest, we will keep it on the other side. Why are we doing that? Because we have to find the minimum velocity. So what will we do next? We will complete the squares. We will add plus gk whole thing square to both sides. We are doing this because we want to complete the squares. We will be having this. Take the square root of both sides. We will be having this. Okay, again we will keep u square on one side, the rest will transfer it, and we will be done. If you take a look at this equation, what this one is saying is the velocity u to pass through the point hk, it should satisfy this equation. It should be greater or equal to gk plus root over h square plus k square. Okay, so u square always has to be greater than this. So the minimum velocity will be when it is equal. This one you will have to remember. Okay, so we are done.